Hi everybody, welcome. Well, after a very long time on my computer, my main computer in the house, I use this to listen to the audio on my computer. This Pioneer SA-7500 is due for some much needed maintenance. The volume control is getting kind of scratchy and staticky when you turn it. I'm starting to hear some pop noise. I think one of the 2SA-726 transistors is starting to go, because this has those, and those are notorious for going bad. So just a few things we need to touch up and get this thing back in ship shape so we can put it back on the computer and use it for another whole bunch of years. So let's get started. I thought maybe you'd be interested in seeing some of these basic maintenance things that you'll do while working on these amplifiers. All right, for starters, we have some speakers connected up in the back there. Let's turn the amplifier on, no signal, and I'll show you the first problem. So if we take the volume, and I'll hold the microphone by the speakers, you can hear how staticky it is. And of course, I normally listen to it just at low volume, so this bottom part is especially dirty. The selector knob hardly ever turns, so it's in good shape. Most of the other controls are all pretty quiet, but we'll clean them while we're at it anyway. And I get a lot of questions about cleaning potentiometers, so hopefully I can share with you the way I do it. And again, I showed this before, and we're going to try even a new product on this one, and I want to see how it works, because this is a heavily used amplifier, and I turn the volume quite a bit up and down, so this will really tell how this works in the long run, you know, over a period of time. So let's get it apart and let's start. Okay, we have the faceplate and the knobs and the covers removed, and here's what we're going to do. First of all, we have to deal with the transistors that are bad. Now, I don't know if this is the equalizer amplifier, so this is the section over here for the phonograph. So if you're using the phono stage, these are the transistors, and they are those two SA-725s. So they will need to be replaced, but I don't use that, so even if they were bad, you would never notice it. Where I am hearing the shot noise is over here, which is the control amplifier. This is where your tone control section and everything is, and your line stage, and those in fact do use those two SA-725s. Definitely one of them is bad and so I'm going to replace all four. These are, I believe these are JFETs here, so they're not going to be bad, they're fine. But I'm going to replace them with KSA-992s for the PNP ones, and then for the NPN, and just because I want them to match, I'm going to use a KSC-1845. Now, looking at each channel, there's one NPN transistor and one PNP transistor, and even though the NPN one never goes bad, this 2SA-725 is notorious for failing. So because I want to have a matched pair, well, not matched as in on the curve tracer, but matched as in the types, or complementary, I should say, the KSA-922 and the KSC-1845 are complementary transistors. That means they're kind of related to one another. They're the NPN and PNP version of that type of transistor. I am using the F series, so if it says the letter F on it, I don't know if you could see it or if it's too blurry, that means that is the specific gain of that transistor. There are gain classifications of the KSA and KSCs, and each of those letters tells you what gain range it's in, so that they will be relatively close to one another in performance. Anyway, one good thing about the Pioneer, A lot of the Pioneer, or most if not all the Pioneer amps from this era, if you look at the screening on there, you see they have the symbol for the base emitter and collector pins. On the Pioneer gear, these are almost always correct. They are very rarely incorrect. You always want to check to make double sure, but on Pioneer gear, Sansui is a different story. If you're going to work on Sansui gear, a lot of times things will be mismarked on the board because either A, they were misprinted, or B, they have done a modification during production and never changed the printout on the board. They're using a different transistor or some sort of thing. So just be aware of that. Anyway, let's replace these two transistors and go to the next step. Kind of tough around the camera here. Alright, so got one pin wrong, but that's okay. We'll tack it back down. Okay, that's done. Now you can use solder wick, you can use just one of those little vacuum pumps. There are many different ways you can do this. If you have a desoldering station, you can use that like I'm doing. Doesn't really matter. And I've done this a whole bunch of times on other videos, so those of you who watch a lot of my videos know this already. So let's pull this out. And you can see there it is. Now, if you look, some of these are painted. In other words, some of these have a coating put on them. And you can see how shiny that is. Like on the leads, that black. And you can see how it stops right above where it goes into the board. You can see they very specifically paint. That's a type of paint that they put on there. They tried to do that to prevent the corrosion from going up in here. Because what happens to these is they get a tarnish on the leads because there's silver in the leads. And that tarnish will travel right up through the case of the transistor and right up to the junction connections of the actual silicon transistor inside. And that's what causes the noise, and the shot noise and so forth. So they tried with this paint to fix that. Now, some of them, that black is not paint. It's actually tarnish. And the way you can tell is if it's tarnish, it'll have a very flat black color. It'll almost look flat black like what you see on a heatsink. It won't have that kind of glossy shininess of this. And it also will not rub off with your fingernail like that. The tarnish, you really have to kind of work on it with a scratch brush or use a chemical to get it to come off. But this paint is very delicate and it can come off pretty easy, and it'll flake off if you keep picking at it. But anyway, this is this 2SA-725. These are what fail. And we're going to replace it with our KSA-992. And I always mark when I buy them because I always forget what order the pins are. It's emitter, collector, base. And I don't remember if the KSA, if the 2SA-725 has the same pin out, but doesn't matter. We'll just arrange this in there so it goes in. If you go back in the video just a minute, you'll see that this old transistor, the 2SA-725, was mounted this way. And notice that one is mounted the opposite way. And that's because the configuration of the original transistor here is base, collector, emitter. So it goes BCE, base, collector, emitter. And if you notice, the new ones are emitter, collector, base. So you can't just take a transistor out and put your replacement one in exactly the same orientation as you took the old one out. You really have to check the pin out and make sure it's in there correctly. So that's what we did here. Anyway, that's how you do it. Another little tip when you're replacing these transistors, the corrosion on the leads is a big deal. So once again, before you put the solder on it, cut the leads to length. Bend them over where they need to be and then cut them to length, how they're going to be. Just kind of above the pad. See that? Cut them before you solder them. Why do you do that? Well, the reason you do that is whenever you snip the end off of that, that coating or the plating of the lead is going to be removed. And the very end of the wire, of the actual wire lead, will be bare copper. That copper is very susceptible to corrosion, and even though that's usually not a big problem, it's always a good idea to do that. Now, I've been naughty in the past, and I've clipped them after I solder them. But if you're going to do this, and you really want to do a top job, clip them first, and then when you solder it, the solder will actually wick into the copper, the bare copper end of the lead, and kind of seal it off a little bit. It adds a little bit of extra protection. All right, I'm kind of doing the best I can around the camera so you can see it, but that gives you an idea of how that works. All right, once you're finished with that, I take a little bit of rubbing alcohol and either a brush that I'll clip some of the bristles down so that it's a little stiffer, soak it in anhydrous alcohol, and just clean off that extra flux so it's just not so sloppy on there. I mean, just do a neat job if you're in here, especially if it's your own thing here, you know. Well, even if you're doing work for others, you want to do the best you can for others. All right, so that's done. I'm just going to replace that 1845 in there as well, and I'll do the other side off camera, and then we'll be back. Everything's back together and looks good. So we're going to move on to over here. And again, I am going to replace these couple of transistors over here, although I don't really think I'll ever use them, but since I'm in here, it'd be crazy not to do it for what they cost. I mean, these are so inexpensive. They're less than $1. So while I'm in there, I'm just going to do it. A little word on that. The way I did things in the past and the way I do them now has changed. And the reason for that is when these things were still big, still around 1970s, 1980s, and you needed to replace a component, there was no internet, there was no Mauser and DigiKey and all those things, and if there was, they were a brick and mortar store. And in our area, we had parts houses, you know, actual places that sold electronic components. In my hometown, there were 2 places, and then outside of my town, there were several other places. But really, you had to drive to these places. You had to individually purchase each part that you wanted, and they were not cheap. A transistor cost a lot more back then than it does today. You couldn't get bulk discounts on, you know, 100. First of all, the stores, if they even had the one that you needed in stock, they only kept a few on hand, so the prices were a lot higher. Same thing with capacitors. They were very expensive back then. So the approach you would use on something like this back then was, if it's not broken, if it hasn't failed, you don't replace it. Because of the cost and all of the travel and everything associated with it, you just replaced what needed it. Today, that kind of approach doesn't really make sense when you can buy 100 of these very inexpensively if you buy bulk. And especially when you're paying a $7 or $8 shipping fee, you pay that same shipping if you buy one transistor or you buy a whole bag full of them. So if you save up and make a list of everything you need, and if you do this a lot, is what I'm saying, you buy bulk, you can get these things very inexpensively, and there's no reason not to just replace these components. Remember, this thing is approaching 40 years old. So even if you can put testers on the capacitors and test them to be good, it doesn't make sense not to replace them for all it costs. while you're already in here, and for how easy it is. You saw how quickly I removed those components and replaced them. So that's just kind of my take on it. I also have really changed my mind about cleaning potentiometers like this, and we're going to get into that when I get this apart. So let me take this out. I went ahead and replaced these transistors back here, and I removed the faceplate from these controls here so that we can get to the pots. Now, 2 of the pots have access through the top, 2 of them do not. Now you can do some things like you can take your heat gun, like I've done here on this, and you can get one of these straws that goes on your can of spray, and you can heat it up and kind of bend it, and you can make some shapes that can get under here to clean in there. But I'm going to do a little more intense cleaning. So this would be for a potentiometer that's been sitting for a very long time, that all of the lubrication inside the pot has dried out and got crusty, and you want to do a little better job of cleaning. So we're going to do a detailed cleaning on a potentiometer here. This is not always for the faint of heart, but when it gets really bad, which this is not that bad, but we're going to do it anyway, and I'm going to try a new product, at least it's new to me, that I've never used before, and we're going to just see how it works with this. Well, I hope you can see this. So what I've done is I've just gently bent these tabs out on this one. Now, a little word of warning about potentiometers. Even though they may all look the same on the outside, you know, they're round and they have 3 pins and the shaft, you know, and so forth, the way they're assembled can be very different. There are modular potentiometers that can be taken apart that have little E-clips. There are also ones that are press fit together, and you really can't totally disassemble them if they fail. This is one such pot. So the only part we can take apart is the last element. So you have there's 4 pots here all ganged together. The 2 front ones are controlled by this outer ring, and they constitute the balance control for the amplifier. And the 2 rear ones are connected to the center shaft, and they are the volume control. Now, if you bend these little tabs out, you have to be very careful, and you can't do this more than once or twice or they'll break off. So be very careful. And you can lift this off, and this will show you what the inside of the pot looks like. Now you can see right here where this particular pot, this is kind of peened over here, so you really can't take it apart. And then sometimes the front will actually have an E-clip that you can remove. This one does not. This is all press fit together, so once it's together it does not come back apart. Some of them you can take things out and then you can slide the shaft out this way, or you can take a clip off the rear here and slide the shaft out this way. They're all different. This one you can't take apart except for the rear, and I just want to show you how a pot is put together so that you understand what some of the issues are. Now this little plastic piece right here, this nylon with the little teeth in it, this would be for a detented volume control. So this one does not have it. Other ones, optionally, you notice there's some holes in here. There's a little spring-loaded ball that can be clipped in there, and that ball will ride in those little teeth, and that's what gives you that detented volume control. This one does not have the detents, it just has the little gear, but it's not used. The other 3 elements do not have this plastic on them. They're just open. Now, if you look, this wafer is the actual potentiometer. And if you look very closely, this black track down here, this is made out of carbon. And this is the actual carbon resistance. It is only attached to these pins here by a rivet. So the pressure of this rivet is all that gives you the contact between this pin and that carbon track. So if these come loose, if you pull on them or move them a lot and loosen them, the pot will not make good contact through this connection to the actual carbon. This carbon is very, very delicate. It is extremely brittle. On top of that, when you use chemicals to clean these, those, if you use the wrong chemical, it will dissolve that carbon. So for instance, some people say that they use brake cleaner because it does a really good job cleaning things. If you use certain types of brake cleaner, it will eat this carbon. It'll just destroy it. Believe it or not, some contact cleaners will do that too. So you've seen me use that electromotive spray. That is good for metal contacts. It is not good for carbon tracks. So never use that. It will destroy this pot. The other thing is, let me show you a couple products. The first thing, and this comes in many different manufacturers and many different names, is electronic contact cleaner. And quick drying, safe on plastics, and so forth. This is mainly just a type of mineral spirits with a propellant, and it will clean and dissolve tarnish and grease very quickly, and it will not leave any residue. It's very good at cleaning things. The problem is, when they make these potentiometers, they actually put a very thin coating of grease in there. It's a special type of grease because that little wiper is going back and forth on top of that carbon track all the time, and you don't want it to wear the carbon away. Again, the carbon is very soft. When you just use this spray, it will clean all of the dirt off of that carbon, and the scratchiness will go away, and it will make you think that it's all right. But what's going to happen is, very rapidly, that problem will return because there's no lubrication between the contact area, which is the wiper. And if we look in here, I don't know how close I can zoom without it going out of focus, but if you look right here, this area right in here, see it? I'll move it. If you move, see the wiper? There's the wiper going back and forth. That's made out of brass, and it's the thing that makes the contact with the potentiometer. And actually, I've actually moved it here a little bit. I'm going to have to fix that. Everything's loose in here right now. I have to be very careful. And when you rotate it, you can see that it moves on that carbon. That has to have a very thin coat of lubricant on it that's obviously not going to prevent it from conducting. And that's what keeps that carbon from wearing down. When you spray this stuff on there, it cleans all of that off and removes it. Now, one of the more common things you see, and everybody uses it on the internet, this is like the internet has made this stuff really popular, is this deoxit. If you notice the letters D5, that means that 95% of what's in this bottle is pretty much the same thing that's in this bottle, only a lot more expensive. 5% is a protectant. It's actually a chemical that's designed to stay behind, and it's the D5, this stuff here, is designed for metal-to-metal contacts. So when we're talking about, for instance, over here, where you just have a metal wiper that's contacting other metal pads, there's no carbon track or anything, this is the stuff you want to use. So if you're spraying a selector switch or a deck switch or something like that, this is good. And if you notice, when you spray things with this, not only does it leave that little coating on the metal terminal, but it also soaks into this wafer, this fibrous wafer stuff, and it keeps it from drying out and shrinking. So it's a really good protectant. The problem is, this doesn't work very well with that carbon. And this is where I used to use this on potentiometers, but I've since changed my mind. That stuff's really not made for this. What it will do is it can, not always, but it can damage that carbon. And Keg Chemicals makes a different product called Fader Lube, F5. Just like this, 95% of it is the cleaning agent, 5% is the actual lubricant. And this stuff is designed to work with conductive plastic and carbon potentiometers. Now, this will work a lot better than this, and it will at least leave a thin coating of something behind to help protect the carbon track in there. But since then, I've found a couple other things that KEG makes, and I was going to try them. The first one, and we can't use on this because we can't get all the elements apart, is this stuff. It's called fader grease. And it works, it's designed to go directly in there, and what it will do is it acts as kind of a little bit of a damping. So when you rotate the pot, it'll have that kind of smooth feel instead of that loose feel. So on some of the higher end pots that you can disassemble, we can put some of this in there. If you can't use that, they now have this stuff, which is, you can see it's a lot thicker consistency, but it's not grease, so you can actually kind of leach it down in there, and that's what we're going to use on this and see how it works. So once again, it's fine to use this cheap stuff to clean the pot as long as it is plastic safe, as long as it is quick drying and leaves no residue. You can use the cheap stuff, but once you do that, you have to put a protectant on there. So that's what we're going to do. I'm going to use this stuff, and we're going to see just what happens. So let me put this back together before we do anything, and then we'll clean it. All right, so there's two methods that we can use. We can just use some of this stuff, this deoxit, and you can kind of hose it down in there a little bit and work the control around, and it should be good to go. What I'm going to do is a two-step process, and you've seen me do this before. And I'm just going to use this less expensive stuff, and I'm just going to put a little bit in there, kind of work it back and forth to clean it. Just like that. And that just kind of washes things out. And I'm going to go down all four of them, like that, and clean it. And I'll go hit this one. And I can feel it get much, much easier to move when you do this, so this needed cleaned. And I know I cleaned it before, but I have a feeling when I did this one, because this was a long time ago, I think I used the D5, and if you notice, it didn't last. It only lasted maybe 5 years or so, or 3 years, I don't know. And it eventually failed again. Okay, so now that we cleaned this, it's very easy to move. You can actually feel it. We're going to wait for that to dry a little bit. This will actually just evaporate and dry. And then we're going to go back and we're going to put this in there. We're going to see what kind of an improvement we get from it. Okay, now that it's dried, I'm going to move this till I can see the wiper there. I'm going to take some of this stuff, and I'm just going to kind of drip it down in there and let it flow down in. The nice thing is it's kind of oily, so it'll run down in there. It's hard to get it to come out. And then I'm going to just work this back and forth so it works it down in. And then I'm going to take a cotton swab and clean this all off. Clean the excess out. And then we're just going to let that wiper carry that lubricant down in there. We're going to see how this works. I hope it works better than the other stuff, but we'll see. Now, again, if this could be disassembled that you could get into it, we could put some of this DFG 213 grease on there, and that would kind of dampen that sound. It would damp that down a little bit so that the pot would feel a little bit more, have a little bit of resistance when you turn it. But we have to just deal with what we got because you can't get this thing apart. Anyway, that's it. We're going to let it soak down in there a little bit. We're going to keep working these back and forth, and when we're done, we'll reassemble. So again, it's difficult to do this really well if you leave it attached to the board, because you can see it's very hard to get this down in here and get it upside down so that you can work the controls and let kind of gravity do its thing. So when they get really dirty like this, you just, to me, it's better to just disassemble it like we did. Take it off the board, clean it properly, and put it back together. I get so many emails about this that I just thought I would go over this once again. And again, I hope that explains the difference between the different types of cleaners and so forth, and the reasoning why you don't always use one type versus another. You know, there's reasons for why they're all different types. The other thing, and I've said this in 100 videos if I've said it once, and that is, if you're going to use this kind of stuff that's in the spray can, and you're just going to hose it down to clean the pot out, again, when you do it on the board, all that stuff's going to run on this board, and that 5% stuff will soak into the board and kind of make it greasy. So you'll get this greasy coating on the circuit board, and the dust, when it starts getting dusty in there, will soak into that, and you'll just get this waxy, dusty paste on the board. It's just gross. And I'm not really sure what that's going to do to, for instance, any carbon composition resistors or any kind of semiconductors that it may leach up into. I don't know what that would do to it. So I kind of try to avoid spraying those kinds of chemicals on the board. And if I do, you notice I always put a paper towel all the way around the pot when I spray it, so that the paper towel can absorb any of the runoff. I don't want that stuff getting on the board. All right, let's put this together and we'll give it a try. We're all back together. Let's see if we achieved success. All right. Nothing. Dead silent. Perfect. Now the big thing is to see how long this lasts, because the original deoxit, which was the wrong chemical for this, as I found out, the D5, did not last, did it? So hopefully this new stuff will last a very long time. We'll see what happens. And while we're in here, let's just go in and touch up the bias, or at least verify that the bias is still good. Let me connect the meter. For starters, you want to remove the preamp out, power amp in links, which these are homemade ones because this amp was missing them. And you want to install an RCA jack with a 5.1K resistor to kind of clamp off the input here. So you can see it's a 5.1K. There we go. I'll turn that down. Next, we want to take our meter and set it to millivolts DC, and we want to connect it from the ground terminal here to pin 3 for the left channel, and to pin 7 over here where we at, I should say 17, yeah, 17 over here for the right channel. And the first thing we're going to do is we're going to set our DC offset. Offset should be 0 volts in a perfect world. You can see it's drifted a wee little bit. Now before you do this, you want to have the amplifier on for at least 10 minutes. Okay, if it has to, you have to wait for all the transistors to warm up before we do this, because if you adjust it when the amp's cold and then it warms up, it'll drift again. So this amp has been on probably for 10 or 15 minutes. And what we're going to do now is we're going to adjust VR1 and VR2, I believe. Or no, VR3 and VR4, I'm sorry. So we're going to go over here, and we're going to adjust these two inner ones. So these two are your DC offset, and these two are your bias. So the first thing you want to do is get your offset. adjusted. We'll see what happens. See, it just barely needs moved. And you have to move it and then let it settle. And we're a little bit spoiled on this because I have replaced these with 15-turn potentiometers instead of the single-turn pots. And you'll find out that when the original pots that come with these are really, really touchy. You barely breathe on them and it jumps a whole ton. So this is a good upgrade to do if you get a chance. Go to the multi-turn potentiometers. Now let's move over to pin 17. Make sure our DC offset is good there. And look, that's perfect on that one. It's within 1 millivolt. That's beautiful. Normally, if you get it within, 10, 20 millivolts, it's not going to hurt anything. So this is exceptional here. And look, it's been years and years since I've touched this thing. Okay, now we're going to check the bias. And in order to measure bias, we're going to go between pins 1 and 2. So let's move this over here. And we're going to go between pins 1 and 2 on this side. And you want about 30 millivolts, and you can see this is sitting a little bit high. So we'll turn this down a little bit. You see how much that jumped? So that tells me that the pot was a little bit dirty. There we go, 30 millivolts. Then we'll move over to numbers 18 and 19. And the bias isn't super critical. The main thing, you just want the transistors to just be barely turned on so that you don't have any crossover distortion. See, that's good. That's 31 millivolts. That's plenty fine. You want it just on enough to prevent any crossover distortion, but you don't want it on any more than it needs to be so that you don't put extra heat in the idle current. In other words, when this thing sits and idles, if the bias is too high, that's what makes these heat sinks get really warm when the amp's not even playing, is because your bias is set too high. And you can see these pots have gotten a little bit cruddy. There we go. So they're good. Anyway, I'm just going to leave well enough alone there, and everything's good. So the amplifier is all set to go. It's biased and balanced, and let's put it together and we'll play a quick song on it. If it's good, we'll put it back up in its home. There you go. It still surprises me, this little 40-watt amp, how amazing the bottom end is on this amp. It's one of the cleanest sounding amplifiers for bass that I have. It even rivals in some way my SA-7500. This thing's just amazing. That's why it sits on my desk. I listen to this amplifier way more than I do anything else, because of course it's on my computer and I'm always watching YouTube or listening to MP3s or whatever there. So, and it sounds amazing on my headphones. It's just a really nice amplifier. So that's it. I'm going to put it back together and take it back up, and it's going to go back and hopefully last another many, many years. So I thank you all for coming along. I wish you all peace, joy, happiness, and good health in your lives. We'll see you again real soon. Bonus footage. On the tube tester video, some of you, I couldn't believe how many responses I got on this, comments I got. You saw this little container of vinegar that I keep on my desk, and everybody asked, is it because I eat fish and chips, or what do I use it for? Well, vinegar is very good for corroded battery terminals, especially the ones that have that white fuzzy corrosion on them, or screw heads that sometimes they get that white crust on them. Vinegar will dissolve it almost instantly. So I take one of these artist brushes and I cut the bristles down so they're short and stiff, give you kind of a scrubbing action, and then I'll soak it with this vinegar, and it's just amazing how quickly you can clean, sometimes you can clean the battery tarnish off if it's not too terrible. So that's what I use it for. It works better than deoxit or any of that other stuff. It doesn't leave anything behind, and it's really cheap. So that's what I use. That's what it's for.